Hello? Is there anybody there? If there is, we thank you for sticking with us for what seems like an age. We finally got the energy to dust off those cobwebs to get this recording nice and shiny for you to listen to, so that continued subscription will have been worth it. Thank you, Marvin Andujar, our incredibly patient guest, star of this episode. So without further ado, we present to you brains, drones, and smart apps for our phones. So, welcome folks to another episode of Two Scientists, where inspiring scientists share their work with you wherever you like to listen. And today's guest is not only inspiring, but his work, at least to me, sounds so much like science fiction. Thank you for joining us, Dr. Marvin Andujar.
Yeah, thank you for the invitation.
You are an assistant professor in the Department of Computer Science and Engineering, and there you're the director of something that's referred to as the Neuro-Machine Interaction Lab. That sounds like potentially you have fingers in a lot of pies and that your background extends to a lot of different things. Is that right?
Yes, so my background is on computer science. So my bachelor's was in computer science and mathematics, and my PhD specifically on human-centered computing, so which is a combination of psychology and computer science and other fields. So I was always interested about the human brain.
Yeah.
Hated biology to be so I was like, this is not for me, but then I love technology.
Yeah.
And I love math. So when I heard the field of brain-computer interfaces, that of course in the medical field, brain-computer interfaces has been around for a while. Mm-hmm. Then it was extending to non-medical work in the early 2000s. And when I was an undergrad, I heard about it and I was like, this is what I really want to do.
Yeah.
So, yeah.
It sounds incredibly cool from the get-go. But I wanted to say, back to the very beginning, I saw a lovely interview with you in the Tampa magazines, which mentions that you're from Santo Domingo in the Dominican Republic.
Yep.
And your parents were your inspiration.
Mm-hmm.
So how was it that you ended up in the US and doing engineering?
Yes, so my parents decided to move to the States when I was a freshman in high school. They thought it was the best move for us as a family. So of course they did the whole green card application to be able to work here in the States. And then when I got to the States, I was a sophomore in high school. Of course I didn't know English, so I had to learn English and learn a brand new system. And then apply for college a few years later. But then in my final year of high school, I was wondering what would be my major. I knew I loved computer science. Well, I love computers. I didn't know what computer science was. And someone said, oh, you should do IT. You should do information technology. You like computers, you like, playing around with technology. So my major was IT when I applied for colleges. Then I take my first computer science class. And in my mind, I thought computer science was Microsoft Office, doing PowerPoint, Excel. Until I see my professor writing code on the board, I was like, I have no idea what is she talking about. Even after that first lecture, I had a big headache. I was like, this is completely different from what I expected. And funny thing is, that's typical. Mm-hmm. People really think that computer science is all fixing computers and Microsoft Office, and it's really not. Right?
Yeah.
We never fix a computer in any of our classes, right? So even though my family think that that's partially what I do, but yes, so that's how I started doing engineering. I still love computer science even when I learned more about it. And then through time, I started doing research as an undergrad. I did research for about 5 years as an undergrad when I was doing double major, and I fell in love with research that I decided to pursue a PhD, and that's why I'm doing engineering still.
Okay.
Yeah.
So, funnily enough, between David and myself, it feels like a mashup of our two backgrounds. So, I'm a neuroscientist and he is a computer scientist.
Oh, nice. Yeah. Okay.
Yeah. So, I'm sure he'll have some probing questions for you at some point during the interview. But kind of going back to your lab and the group that you started, I guess the first thing I want to know is, what is the history of these kind of
brain-machine interfaces. So for something like prosthetics and creating new limbs and kind of being robot humans, I can see that as a natural progression, right? But when it comes to the idea that you're going to use electrical activity in the brain to power something that's somewhere else, how did that come about? And essentially, what is it that you do in your research?
Yes, so even back in the 60s, 50s, there was a lot of work done with electrical signals, using EEG sensors to be able to get electrical signals from the brain for different purposes. We saw that, of course, in psychology and in understanding more in neuroscience, right? So using EEGs and also MRI machines. But the term brain-computer interfaces didn't exist until the 1970s. And the idea behind it was to use our brain activity actively. So if I'm imagining a movement in my head, we associate that with a task, meaning that can I open a door with my brain? And that started more, instead of just collecting data and saving it, of course, for analysis purposes and for other great things, then it's how can we use that for applications? So neuroprosthetics, people in a wheelchair, can they move the wheelchair with their brains? Thankfully, with the findings from neuroscience and cognitive psychology, we have learned enough about the human brain that the computer scientists said, well, I think we know enough now to be able to do a lot of work outside medicine, or help them also through machine learning, signal processing, to be able to get better signals from the brain with our devices. So the work that we started, at least when I started doing brain-computer interfaces in the early 2000s, I was an undergrad. I was doing a summer program for undergrads at Clemson University. And at the time, he was just my RU advisor. Then he became my PhD advisor later on. And then he shared that idea with us before we got to the lab that summer. He said, well, brain-computer interfaces. And I asked, what is that? And he said, well, we're trying to combine the human brain with technology. I was like, this is it. this might be my field. And then when I got there in the summer, they're like, well, we're about to start this here, brain-computer interfaces. So I started working with one of the PhD students. Now he's a principal engineer at Intel back in the West Coast. And then we started coming up with ideas and said, well, we don't want to do neuroprosthetics. We don't want to do wheelchair, because that's more in biomedical engineering. We're computer scientists, so we need to come up with our own ideas that is outside of it. So we started looking into how can we use BCIs for education purposes. Then the Brain-Computer Interface Society, just a few years back, created a roadmap on where do we want to see brain-computer interfaces in the year 2025. And one of them was, can we use BCIs for education? And the idea is like, can we track engagement of students, cognitive workload using EEG, right, using brain-computer interfaces, and then provide feedback to those students so they can have a better learning experience. So that's what we came up with. We did some work on that. And then, of course, once I became a PhD student, I met my colleague called Chris Crawford. He's assistant professor at University of Alabama right now. So we did our PhDs together. And when we started, the great thing about it was that my PhD advisor allowed us to work on any project that we wanted because it was open field at the time. And then I asked my colleague, say, hey, what are you working on right now? He's like, oh, not much. Our advisor has me working on this project, whatever. And then I said, oh, we should work on brain-controlled drones. And he looked at me like I was drinking something. It's like, Marvin must be drunk right now. I was like, yeah, brain-controlled drones. The reason why I brought it up, it was because he was working on drones before, and I was already working on brain-computer interfaces. So I wanted to combine both of them. So that's how our work on brain-controlled drones, brain drone racing, came along. And we did a brain drone race back in 2016, and of course we did one here at USF back in 2019, if I'm not mistaken. So yeah, that's working on some of the things I'm working on now.
So expanding on the brain drone racing, you have a very nice little TEDx talk that you gave a while back, which we'll link to in our show notes. But it starts off as a fairly standard, like, we're doing some cool things with tech. but it actually becomes a much more profound conversation about how we can use or utilize these things to help people with disabilities and level the playing field. Can you actually tell us more about this specific race and what it is that you think that it achieves?
Yes, so once we had a prototype on the brain control drone technology, which we started back at Clemson University, and then my advisor moved, so we moved with him. We moved to the University of Florida. So we were just sitting in the lab and we started thinking, what's next? So we have a brain control drone. I mean, we can always do the computational aspect, make it more accurate, but we wanted to do something more than just that. So we came up with the idea of brain drone racing. Drone racing in general started to take off.
Right.
That was back in 2015, 2016. And then we were thinking, how about if we do something similar to like brain drone racing? And the whole goal of that brain drone racing was to educate society that brain-computer interfaces exist, and that is not science fiction.
Yeah.
Right. So even still today, people say when I tell them the stuff I work on, they're like, "Wait, so are you talking about the movie, Stranger Things, Star Wars?" I'm like, "No, this is real." Even when I show videos to some people, they still don't believe it.
Yeah.
They're like, "Oh, we can always fake videos and think, no, this is real stuff." So that's why that was the main goal of it.
Yeah.
So I would say a few days before the race, the Associated Press wanted to cover the race. And they sent us an email saying like, it was like about a good paragraph telling us like, well, we want to be honest. That's what AP told us. We don't believe this is real. This is like 48 hours before the race.
Right.
Yeah. They're like, we don't believe this is real. We talked to our editor, is skeptical. We emailed MIT and Harvard and whoever, and although they say that it's possible, we're still skeptical. They saw a video that were covered by Fox News at the time. They still didn't believe on the video. So I was like, how can I convince the Associated Press to travel to Florida to cover this race? And I pretty much told them, well, look, the only way you're able to see if this is real is by coming here and try it yourself.
Yeah.
Right? Every new technology, people always are going to be skeptical.
Yeah.
People were skeptical about planes. The fact that you put hundreds of people in a flying submarine to go from one country to the other.
Yeah.
So, and that's exactly what I said in the email. I said, look at us now. We use planes every single day.
Yeah.
And he pretty much said, see you on Saturday.
Okay.
Yeah. So, and they, of course, they covered the race. They tried it. They saw that it was real. We had students racing. And after the coverage from the news, which was covered by Discovery Channel and New York Times, the response that we got from society about it, that's when we saw that regardless of gender, your physical abilities and disabilities, you can compete in the same sport.
Yeah.
That's when we're like, wait a second, this one can be the one that is the most inclusive sport.
Yeah.
Because only your brain is needed.
Yeah.
Right? So I could be 50 years old and compete against somebody who's 20, 30 years old, as long as I'm keeping my mind in shape. And again, they don't have to worry about someone being taller or stronger. It's all about your capabilities of concentrating for a long period of time.
Yeah.
And that's when we started thinking, we may have something here that we can provide to people that is more inclusive than what we have right now in society. So that's why we started doing more races. My colleague at University of Alabama did his own race, and we did, of course, one here at USF. And we hope to do more races in the future and make it more applicable at different universities. Yeah.
It does sound very exciting. I'd love to come and see it. So, David hates sharing stuff on the microphone.
Okay.
I forced him to start doing the interviews in Spanish, but other than that, so he asked questions via Messenger. So he said, if your life depended on it, is there anything you would still trust a human to do with a regular interface that you wouldn't with a neural one?
That's a great question. I also, as of right now, I wouldn't depend on a brain control, much depending on the person, right? So, not myself, but other people at least had people driving a Formula One car with their brains, right? I definitely will not get in a car and they tell me they're about to brain control their car. I think I'll prefer autonomous at that point.
Yeah.
Controlling in video games, definitely I'll trust it, right? So simulations, virtual reality, of course the brain control drones are great as long as it's in a safe space.
Yeah. And presumably for each one of these things, like in order to be able to use it in real life, people would have to train up.
Yes, that's a great point. People always ask me, even in my classes, it doesn't take long to train or to get used to it. It really depends on the person.
Right.
So I always use the example of athletes. Some of them are natural, and some of them really need to train for a long period of time to be able to catch up to that who is a natural.
Or some of us will never get to that point.
But when it comes to brain activity, we can, right?
That's true.
So it takes a few seconds, a few minutes to be able to train, but then it takes days, weeks for mastery.
Right.
And of course, our technology still need to improve for us to be able to do things that is more real time.
Right.
The second part of it, we're asking people to use their brains in a way they had never used it before. So when we walk, we don't think, oh, I need to walk. We just walk.
Yep.
In this case, I'm actually telling people, imagine yourself walking to be able to generate that brain activity so you can control this drone. It's a completely different way.
Yeah.
Kids, they're great at doing these things, right? Because they're still, they're more creative. They're not adults. Adults, they take a longer time to be more creative with those thoughts.
We're talking a lot about how you actually use these things, how you implement them, but can we backtrack a little bit and exactly what does this thing look like? How does it work on a very practical level? How is it that a brainwave or something happening in your brain can then be translated into a physical thing happening over there?
Each part of our brain have their own functions. That's all thanks to neuroscience and cognitive psychology that they have studied and find out what are the functions of each part of the brain. So we try to grab those electrical signals using what we call neurotechnology headsets nowadays. Neurotechnology is typically any headset that we're able to get brain data information from people.
Yep.
It could be either non-invasive, meaning that just on top of their head, or invasive, meaning that it will require surgery.
Okay.
In that case. So the work that I do is mainly, of course, non-invasive. We get the electrical signal from the brain. Of course, we have to clean up that signal from any noise, any unwanted data, like muscle movement, eye blinks. We clean up all that. We're using algorithms. And then using what we call machine learning algorithms to be able to classify those signals into that particular task. In general, that's how we're able to get those electrical signals from the brain and classify them to a specific application. So an example I can give you that I always use is when you're driving and we're able to detect if you're falling asleep.
Yeah.
So we have something called theta. We all have that theta wave in our brain activity. So it's more related to drowsiness right before you fall asleep, which is your delta stage. So if you're driving and you're wearing a brain computer interface, or what we know as a neurotechnology, as soon as we detect your mainly that theta stage, then your car probably can give you a notification saying you may want to pull over, you're about to fall asleep.
Oh,
right?
wow.
Or in this case, if you're driving in a smart car like Teslas or another electric car, then they will start the autopilot right before you sleep and then park for you at a safe space.
Yeah.
So that's the idea of how we can use this type of technologies and how it will work in practicality.
So, I mean, looking at your webpage and the various things that you do research on, there's a lot under there. But one of the other practical things that I noticed that came up, a specific example is ADHD and helping people improve concentration.
Yep.
So how does that work? Because as you mentioned with a theta wave, you have something very specific you're measuring. Yep. How do you measure something like concentration and use that in people with ADHD?
Yes, so in that case we look into what we call beta waves. So it's more related to alertness and concentration. Of course we look more into other waves as well, and we use what we call the engagement formula, where we look into alertness and try to remove drowsiness and relaxation from the attention data. So the idea of improving attention for those with ADHD came about because of the community. So every time I did a demo with brain control drones or the simulation that we have, Adults will just come to me and ask me how they can buy the technology because they would like to use it at home to train their attention because they have ADHD.
Yeah.
And then when I have done presentations and they have mentioned like, oh, this may be useful to train your attention, I get someone in the audience with ADHD saying, I wouldn't want to use drugs, I want to use this.
Yep.
So the community pretty much told me, you need to start working on this. They're like, you need to help us out.
Yeah.
And that's when we started looking into brain art, what we call brain painting.
Okay.
To be able to create your own abstract paintings with your brain, where you concentrate on a stimulus. So it will be, you concentrate on different objects and colors in the screen, and then you can create your own art. The reason why we decided that method to be able to improve attention is because you had to concentrate for a long period of time. So if I try to brain paint, create my paintings with my brain, and my phone rings, then and I pick up my phone, I get distracted. So I'll be selecting the wrong object or the wrong color, or the system will not be able to select anything at all.
Yeah.
So now I had to go back to it to concentrate on what I was trying to select. So that mental discipline it can be trained. And then the number 2 part of it is doing the brain painting in a virtual reality environment. The reason why we decided that is, one, you're more immersed in your own painting, and we're trying to find out if we can improve your mental health. As art is related to improve health, mental health in that sense, being inside your own painting, you will be less distracted.
Yep.
Because you'll be more immersed in the painting and the activity that you're doing.
Yeah.
So that's what we're collecting data right now with participants, and we're trying to hopefully see some improvement there over time.
I have to say, it feels like it must be really nice to have a very tangible impact of your research on people. And related to that, and actually this is one I was thinking of as well. So David says, your work seems to be at the intersection of many disciplines. Who do you work and collaborate with?
That's a good question. Mostly I collaborate with other computer scientists currently that look into emotional data. I'm looking also to collaborate with neurosurgeons. So after the brain painting work has been in the news recently, there was some neurosurgeon that have reached out to me asking me if I have thought of using brain painting for those who have experienced stroke. Mm-hmm. And I haven't, right? So I have been concentrating with ADHD, and I hope there's a potential collaboration there. But then also, those who have experienced stroke have emailed me after they saw that in the news and said, have you thought of using brain painting? Because I have experienced stroke and I think this will be useful.
Yeah.
And of course, there has been others with dementia. And dementia definitely is one that is personal to me. My grandfather passed away of Alzheimer's a few years ago, after 12 years of fighting with it. So I'm highly interested to see how I can use this work to help those with dementia at the early stage, right? Because once it's late stage, it's hard to really do anything. It's that early stage, early detection, help caregivers.
Yeah.
Can we help them improve their mental health? Because they go through so much, right? Especially if they're family members.
Yeah.
I saw that firsthand with my mom, seeing that her own father didn't recognize her. So if I could have helped her with my own technology in some ways, that's where I want new collaborations to start so we can help them long term.
Yeah, that's quite the motivation.
Yeah.
So he had another question. My phone is weird. It likes my left thumb, but not my right thumb to unlock.
You need a brain-controlled phone.
I do. I need a brain-controlled phone. I don't know. I think it still freaks me out a little bit to some degree, and I wonder if people come up to you and they actually tell you that I'm too nervous to kind of interact with these technologies.
So people haven't told me that directly, that they're scared of the technology. Well, actually, I did have a faculty tell me that before, that she was scared of the stuff I was working on. Yeah. Which was interesting because she was also a researcher.
Right.
I guess it's when I start talking about brain control, anything, people start looking into like, okay, wait, that sounds too science fiction. When I have seen posts in social media, sometimes I do check the comments, and I have seen mixed opinions about it. Of course, some positive opinions, Some others have been scared about it, saying the future is scary. Some are concerned of getting the brain hacked. As of 2022, that's not possible. I just, even scientifically speaking, I cannot think of how can that be possible yet. They're concerned of the government implanting information into their brains. Again, it's not possible, at least as of right now. And of course, then you hear people like Elon Musk having his own company called Neuralink and start talking about downloading and uploading information from the brain and associating things like with the Matrix.
Yep.
People get scared, right? So, and when people bring that to me after I give a presentation, I say, yeah, that's not possible yet, right? So maybe in the next 100 years, but we still haven't gotten there yet, right? So it's a concern for people, which is understandable, right? So this could be privacy concerns, ethical concerns that we have to always consider. But I would say most people are always just find it more interesting. Like, okay, what else can I do with it? Can I just be lazy and have Netflix adjust based on how I feel, or have my home adapt based on my emotional state, right? So those are the type of things we talk about.
Yeah, I mean, there is so much interest in technologies, and I think all of us are very into the idea of how they can improve our lives and make it more cool and fun and, as you say, inclusive and accessible. You know, more people can be brought into the fold in certain activities.
Right.
But at the same time, certainly with the brain stuff, like, we don't even know where memories are held in the brain. Like, there's enough of the brain that you understand to be able to develop these technologies. But the idea that we even know what bits of the brain connect to each other, there are trillions of connections, we're just nowhere near that yet.
I agree. So that's why I always say the brain is the ultimate frontier. We know a little bit, and there's so much more we don't know. But at the same time, I actually have been saying this for the past 10 years, that it's the golden time to get into this field. One, because it's so open. There's so many questions that we need to answer. My biggest goal is, how can people start using this type of technology at home, just like how they use their watches? Because it's a wearable computer, right? So it's a smartwatch, it gets information from you, like heart rate. In this case, it will be a neurotechnology getting brain data for other purposes. So it's how can we get there first, right? And then we can answer the other questions.
So that leads very nicely into David's next question, which is, if anybody wanted to do what you do you have any advice, and what type of personality does it take?
Oh my God. Great question. So the beauty about it is you could be an electrical engineer, computer scientist, biomedical engineer, psychologist, any other neuroscientist, of course, and contribute from that side of your field. So, for example, I'm teaching the class right now for both undergrads and graduate students, and some PhD students from psychology and biomedical engineering. They're taking my class. They don't get to do the development side of computer science, but they get to learn the science behind it. So they can always, of course, learn, if they're looking more into the science side of it, which is not development side, they can always learn more about the signal processing side of things, machine learning, classifying these signals, this data, understanding more the brain to be able to control specific machines and in different ways. Personality-wise, it takes a lot of patience because these are very hard problems, right? Yeah. So when I tell my students, oh yeah, let's create this application where we're able to create paintings with your brain, they look at me like if I'm going crazy. But at the same time, it's like, this is what we do. This is what we PhDs are supposed to do, is create things. And we have the technical skills and the science behind it to be able to make it happen. So it's being patient, a lot of perseverance. So that's what it takes.
So we've talked about how other people should consider going into this field. But in your own lab, imagine everything works as well as you could possibly hope for. What do you think your group can achieve in the next few years, and what does that mean to society?
Oh, if we can do the best. I can start with the brain painting project, as that's my current biggest project in my lab. My goal is for people to start using brain painting applications at home. If we can work at the best pace, I would like to start incorporating those type of technologies at home, where people can say, you know what, I have ADHD, or I would like to use it because I would like to improve my mental health. I can just get brain painting anywhere.
Yep.
Right? It's not just in the lab using a $20,000 device.
Yeah,
right?
yeah,
It'll
yeah.
be more consumer-based, people can actually afford. When it comes to the brain control drones, I definitely would like to see more universities doing their own brain drone racing. Having a college league, a professional league where someone who is in a wheelchair can compete at the same level who's someone who's not in a wheelchair. Because all it matters is your brain.
Yep.
And that's like my overall goal, is to get there and create more applications that can we use our brain activity as a password to secure our data with our brain activity. That's some of the things we're also working on. I know we are in voting season now, and we have a project that you can vote for a candidate with your brain.
Oh, wow.
Yeah.
I mean, okay. How controversial do you think that would be, given right now?
That's why I don't even want to touch that too much. Yeah. So, but it's in that case, can we help people with physical disabilities to independently vote?
Yeah.
Right. So with the brains, and besides that, to authenticate the right person who's supposed to be voting for your account, your brain activity is your own unique biometric.
Yep.
Nobody can replicate it. So we have been thinking about things like that maybe in the future it can become reality. But you know, it's, when it comes to politics, it can get interesting. Yeah.
For someone who didn't even know that these things existed, so what could I have in my house right now that I can control with my brain?
That's a good point. So like simulations, video games, not necessarily for fun. It could be for fun, for entertainment purposes, but it could be for meditation.
Oh, okay.
To be able to relax, to meditate. It could also be for attention training, like I mentioned before. But the idea of relaxing, that I'm able to actually detect your relaxation levels, is applicable today.
Very cool. That's something I'll have to look into.
Yeah.
Well, thank you so much for your time today, Marvin. It's been an absolute pleasure.
Yeah.
And we look forward to seeing where your research goes.
Yeah, no, thank you for the invitation. Glad to be here. Funny thing is, some of my students have asked me, they ask me the craziest question, which is great. They're like, oh, if somebody's on cocaine and they're trying to do this, I'm like, first of all, I cannot do any of that. I'm pretty sure the RB will not be happy. So, okay, what happens if somebody's drunk? I'm like, I guess it's possible to look into it, but I am not touching that.
How will they carry on now that she's gone?
You've been listening to Two Scientists, directed, edited and hosted by me, Pambe Bahia, and co-produced by David Basanta Gutierrez. The Weezer-esque wonder you can hear in the background right now is a track called She Doesn't Live Here Anymore, and we thank Tampa-based The Easy Button for allowing us to feature it. Go to our website twoscientists.org and find our links to both Marvin and his work, as well as The Easy Button, to find all the best ways to download their tunes.
At Christmases and New Year's parties, she sat at the kids' table, crying, wanting more. Now there's no one to speak at the PTA, but someone said they like it that way. There's no complaints. She doesn't live there. She anymore. She doesn't live there. She doesn't live there. Now the outdoor patio shop is her sanctuary non-stop. Rearranging furniture, or has it been arranging her?
I like that you're having to prime yourself with alcohol first.
Oh, yes,
This
yes.
is going to be good.